Hi, my name is Harneil, and this video is going to show you how to create your own custom connector using SWOOD. The objective, so we're going to create a custom connector for the Hafele Rafix 20 connector so that it can be dragged and dropped from our SWOOD connector library and onto our frames. The connector will add both pieces of hardware as well as the cut extrude features onto the panels. The quantity of how many connectors get inserted will depend on the width of the panel, but they will always remain equally spaced to each other. The offset value from the first and the last connector to the outside edges of the panel will be a default value of 32 millimeters, but we will allow for a custom import value if desired. So firstly, this is the specification of this particular connector. So we've got two cuts features that will be added onto both sides of our panel, as you can see there. And then we've got two pieces of hardware that need to be inserted. So the top two images there are the holes that we must create, so a total of 3. And then we've got the two pieces of hardware that we are going to insert. So this is the generic workflow that we are going to follow to create this custom connector. So step 1, first and foremost, you must have the 3D CAD data of the hardware itself, whether you download this from a supplier's website or you can model it inside of Solidworks yourself. You can then build a connector item for each individual cut feature that is required. You can then build a connector item for each piece of hardware which you wish to insert. You can then bring all the hardware and cuts into what we call one compound item so that you can then drag and drop all those things in together at once. Then if you want the number of connectors to increase depending on the width of the panel, you can then add the maximum number of instances that you'll ever require into a much larger compound, and then finally we can write the code to vary the number of instances of connectors that get placed inside our frame depending on the width of the panel. So here's the 3D CAD data that I have modeled in Solidworks. So on the left side we've got the Rafix connector housing that will get placed in kind of the horizontal panel of our frame. And then we have on the right side the screw fixing, which will get placed inside the vertical panel inside our frame. So once we have our 3D CAD models, we can now start building our cut features. So first we're going to create the two circular cuts that will be on the horizontal panel. And if you look at the illustration in the bottom left corner, there'll be one larger circular hole of 20 mm diameter and then a smaller hole of 10 mm diameter. So we're going to use the connector library manager to build these cuts. So inside of Solidworks, on the SWOOD library tab on the right hand side in the task pane, if you click on connectors and then right click where it says connectors at the top and edit to load up the connector library manager. If you click on the icon in the top corner and create a new library of our own, and I'm just going to name this Rafix-20. Just going to right click on Rafix-20, and then within this new library we've created, we're just going to create a new hole feature. So within the drop down of the new, you'll have the option for a hole. Going to name this hole to something sensible, so I'm just going to call it 20 mm hole, and then click on this and you'll have this illustration on the right hand side. So first thing we choose whether we want the hole to be created on panel 1 or panel 2. So panel 1 is this horizontal panel where it's going to show the preview at the moment. Panel 2 would be the vertical panel, and you can see the preview changes. We're going to set this to panel 1, and then we need to choose which of the four faces is the hole going to be placed on, and for us it's going to be face 4, so the underneath face. We then type in the dimensions we require, so it's going to be 20 mil in diameter, it's going to be extruded up a depth of 14.2, and it's going to be offset from the edge of the panel 9.5 millimeters, and this is all based from the technical illustration in the bottom left corner. You should see the preview there. You'll see like a red body that represents the hole feature itself. Once we're happy with that, we can then right click on Graphics 20 and create a new hole again. This time call this 10 millimeter hole, and then select this one and you'll get the illustration again. So again, this is going to be on the same panel, and it's going to be on the underneath face, so face 4, and then we put in the dimensions required for this one, so 10 mil in diameter, 10.5 mil in depth, and it's going to be a total of 41.5 mil away from the outside edge, and that's just adding the 32 to the 9.5 to get that value. Just going to click the green tick and save our library. Next, we're going to create the hole feature on panel 2. So this is a 5 mil diameter hole with a depth of 8 mil. Now, this is where we're going to start getting onto the coding side of things, because the location of this hole is always going to be 9.5 mil from the bottom of the horizontal panel. Now, the panel thickness will vary from frame to frame, so we need to code it so that depending on the thickness of our panel, which is AH, then the height of the hole will always change so that it sits exactly 9.5 mil above the bottom surface. The default position of this hole, so if we just left the location as it is, it will sit exactly central to the panel. And if we just play this video, where we want to move it to is the total thickness divided by 2 down, which is minus AH divided by 2, and then plus 9.5. So I'm just going to play that again. So from its default position, we're going to go half of AH down in the negative direction. So that's minus AH divided by 2. And then we're going to go back up in the positive direction, 9.5 millimeters. The distance of this is coded in SWOOD as TRDEC. So our code must read TRDEC equals minus AH divided by 2 plus 9.5. So back into Solidworks. So in our connectors library, we're going to right click new on Graphics 20 to create a new hole. I'm going to name this 5 millimeters fixing hole. That's what I'm going to call it. So firstly, is it going to be on panel 1 or panel 2? In this case, it's going to be on panel 2. Size of the hole is 5. Depth of the hole is going to be 8. And then the distance here, so if we just leave that value as it is, and that's TRDEC. So we open up this script editor, and in here we can type TRDEC equals, and then in brackets, minus AH divided by 2, close brackets, plus 9.5. You'll notice that the area goes red when the equation is incomplete, but then it comes back white when the equation is solvable. So just looking in test mode here now, what you should see is that the hole, this kind of yellow body, will always be 9.5 mil from the bottom of the shelf. So when it's 20, you can see, and see when it's 30, you can see it's just a third of the way up. When it's 9.5, you can see it's exactly on the top surface. So that's a little test there where you can try out different measurements and just see if the hole is moving as required. The next goal is to add a connector item for each piece of hardware. It's important to recognize the location of the origin on your 3D model, as this will be the default location for the connector. So for this housing component, the origin is sat here where the blue circle is. So by default, the origin will sit central between the two panels, and therefore the default position of our connector would be what this image preview is showing here in the bottom right corner. To move the position of the origin to our desired location, we must move it to the right, which is in the z-axis. So in the z-axis, 9.5 millimeters, and then we need to move it down so that it sits just 1.2 millimeters below the bottom of the panel. So that means we're going to take it down in the y-axis, minus AH divided by 2, so minus half of AH, and then minus a further 1.2 millimeters. So back into Solidworks, if we right click our Graphics 20 and select a new, and this time the option we want is custom. Just going to rename this component housing. And then with this item selected, we can click on the Solidworks part icon at the top menu. And from here, we can browse to any part file of our choice. So I'm just going to browse to the connectorhousing.srdprt file and open that up. Now annoyingly, we don't get to see a preview of the component in the graphics window. So a quick trick is to use the add new body option on the right side and browse to this same file. This would normally be used if you just wanted to cut away or add material to a panel instead of actually inserting a component. But by doing this, it allows us to actually get a visual preview so we can verify the positioning of our component. I'm going to click on the evaluation tab and I can now start typing my script. So to move it in the z-axis, I'm going to type p.z equals minus 9.5, and then for the y-axis we're going to type p.y equals minus AH divided by 2, and then minus a further 1.2. So p.z stands for position in the z-axis, and p.y stands for the position in the y-axis. Just going to click on the test mode just to verify the positioning, and we can see that it looks exactly where we desire. Don't forget then to just remove this new body function out, as it's going to leave an unwanted cut if you kept it there. It's now time to add the next component, which is going to be the screw fix. The origin of this part is located on the center of this surface that will sit flush with the left vertical panel. Similar to the 5mm hole, we must move this screw fix up in the y-axis so that it always sits 9.5mm from the bottom horizontal edge of panel 2. So therefore the script's going to be minus AH divided by 2 plus 9.5 in the y-axis. So right click Graphics 20, new, and create a new custom item. Going to name this one fixing, and then with this selected, we're going to click on the part icon at the top and then browse to the screwfix.srdprt file. Again, we're going to use the add new body trick just so that we can get a visual preview of where the screw fix is going to be. So click OK to that. And then we can click on the evaluation tab and start typing our script. So p.y equals minus AH divided by 2 plus 9.5. So I'm just going to go into the test mode, and I'm just going to change the thickness of AH and just verify that the center of our screw fix will always remain 9.5mm offset from the bottom edge of that panel. For the sole purpose of tidying up my library, I'm just going to create some subfolders for the holes and the hardware, and then I'm just going to drag and drop the relevant items into the subfolders. So I've just created a holes one, and now I'm just going to right click new folder again and call this one hardware, and then simply drag and drop the hardware items into that folder. Now to bring all these items together, we must now create a new compound item. So right click new, and you want to select the bottom option for compound item. Just going to rename this part graphics single. And then with this selected, to add the items into this compound, we need to drag and drop them onto the right area. So the 3 holes are dropped in, and now I'm just going to drop in my 2 pieces of hardware. So all 5 items now become part of that compound. It's now time to get into our rules for this connector, and these are as follows. When the width of the connector is less than or equal to 100, then no connectors will be added in. If the panel width is then less than or equal to 300, so between 101 and 300, then one central connector will be added, and that will sit bang in the middle of our panel. If the panel width is less than or equal to 600, then 2 connectors will be added, and these will be both with a given offset from the outside faces, which in our scenario will have a default value of 32 millimeters. If the panel width is less than or equal to 900, then 3 connectors will be added, 1 bang in the middle, and then 1 on each side with the given offset from the outside faces. If the panel width is less than or equal to 1200, then there'll be 4 equally spaced connectors with the given offset from the outside faces. If the panel width is less than or equal to 1500, then again there'll be 5 equally spaced connectors this time with the given offset from the outside faces. If the panel width is less than or equal to 1800, then we will have 6 equally spaced connectors with the given offset. And finally, our last scenario will be that if the panel width is less than or equal to 2100, then there'll be 7 equally spaced connectors with the given offset from the outside faces. So we must now create a new compound, and I'm going to name this one graphics series. And then with this selected, we're now going to drag and drop the graphics single compound and add the maximum required instances that are required. So for our biggest scenario, we go up to a total of 7 connectors. So I'm going to drag and drop in 7 graphics singles. Then I'm going to click on the script editor, which will open in its own window, ready to write out the first scenario. So quick recap over scenario 1. So if the panel width is less than or equal to 100, then the connector's quantity must be 0. So that means that all instances of our connector must be suppressed. So within our script window, we're going to start typing our if statement. So if AL is less than or equal to 100, then now if you look on the right hand side, you'll see that each instance has its own kind of C number, which is the alias, so from C1 to C7. So I'm just going to type in a list of every single instance. So C1.S equals true, which means the suppression state of C1 is true, and just going to do that for the remainder of the instances. So every instance is suppressed. So true equals suppressed, false will equal unsuppressed. And then to finish off an if statement, we just type end if, and you'll see the preview become white. Scenario 2, so if the panel width of AL is less than or equal to 300, then the connector's quantity should be 1. So C1 in our case will then become unsuppressed, and the position of it will be bang in the center, which is actually the default position. So back to the script. Before the end if, we will type our next scenario of else if AL is equal or less than 300, then we can just copy and paste the same list from above and change the C1.s to false. So that means that that instance will not be suppressed. As the location of C1 is going to be bang in the center of our panel, we don't need to write any extra script for positioning. The third scenario is else if AL is less than or equal to 600, then just going to copy and paste the same list from the top, and this time change the C2.s to also equal false. So that means both C1 and C2 will both be unsuppressed and the rest will remain suppressed. Now before we get into the positioning of these connectors, we must close the script editor and create a new distance parameter using this icon here. Going to give this distance an alias name of OFF, so that's the name that we will use in the script, and then give it a descriptive name and call it offset, and then we're going to give it a default value of 32 millimeters. Going to click back in the script, and now we can write the location position of these connectors. So C1.p.x will move it in the x-axis, and if you just look at the video in the bottom left corner, so we're going to go AL divided by 2, so half of AL, which will take it all the way to one side, and then we're going to minus the offset, which will bring it 32 millimeters in. And then for the second connector, so C2.p.x equals minus AL divided by 2 to take it all the way the other way, and then we're going to plus the offset to bring it in 32 millimeters. Scenario 4 is else if AL is less than to equal to 900. Just going to copy and paste the code from the scenario above and make C3 also unsuppressed. So that means there will now be a total of 3 connectors unsuppressed. The code for C1 and C2 will be exactly the same as the last scenario, and then C3 will just be placed in the central default location, so we don't actually need to put any code in for C3 either. So I'm just going to put in a comment. So if I just put an apostrophe and then I can type in any comment text of our choice, so C3 will be the default central position. So if we just play the video at the bottom, so C1 will be AL divided by 2 minus the 32 mil offset, and C2 will be minus AL divided by 2 to take it the other way, and then plus the offset, and then C3 will be the default central position, so no code required for that one. So scenario 5 is else if AL is less than to equal to 1200. Just going to copy and paste the code from the scenario above and switch on connector 4. So just going to change that value to false. The position for connectors 1 and 2 are going to be identical as the last two scenarios. And then we need to work out how we can position connector 3 and connector 4 now. So if we just watch the video here at the bottom, so connector 1 and 2 will remain where they are. Then connector 3, we're going to take it all the way back to one end, so half of AL minus the offset. Then if we look at the distance between both our connectors, that's the value of AL minus 2 times the offset. If we split that area up into 3 equally spaced sections, that will give us the locations of connector 3 and connector 4. So connector 3, we must then minus AL minus 2 times the offset divided by 3. And then for connector 4, if we put in the same code as connector 2, but then we must plus an additional AL minus 2 times offset divided by 3. So C3.P.X equals, copy the code from connector 1, and then also minus on the end of that AL minus 2 times the offset divided by 3. And then C4.P.X equals, and this time I'm going to copy the code from connector 2, and then on top of that also plus AL minus 2 times offset divided by 3. Scenario 6 is when AL is less than or equal to 1500. Just going to copy and paste the code from the last scenario, and we're just going to switch on connector 5. So I'm going to change that value from true to false. The positioning for connector 1 and 2 is going to be identical to the scenario above. And then I'm just going to paste the code from C3 and C4 as well, and then make some minor adjustments. So if we look at the video below, connector 3 is going to follow the same route again as connector 1. So it's going to go half of AL minus the offset. But then we must now split the region up into 4 segments, and it's going to go a further minus AL minus 2 times offset divided by 4. So it's going to go a quarter of the way in that gap. And then connector 4 is going to follow the route of connector 2, but then go a further AL minus 2 times offset divided by 4. Connector 5 will remain central, so we won't need to write any code for that, so that's going to remain in the default position. So we just need to change our divided by 3 value to 4 for both those lines. And then again, no code necessary for connector 5, so we're just going to type C5 will be the default central position. Scenario 7 is when AL is less than or equal to 1800. I've just copied and pasted the code from the scenario above and changed C6 to equal false, so that's also now unsuppressed. The code for C1 and C2 will be identical as the rest of the scenarios. We're now going to change the code for C3 so that instead of divided by 4, it's now going to be divided by 5. So if you just watch the video below, so this time we must split the area between the two connectors up by 5 equal regions. And then we're going to move the third connector a fifth of the way along this region. So going to change the 4 in our code to 5. Then for C4, we can copy the same code as C3 and just make this 2/5 of the way along. So it's going to follow the same route as connector 3, but it's just going to go 2 times AL minus 2 times offset divided by 5. And then for connector 5, we can do the same, but this time make this 3/5 of the way along. And then finally for connector 6, we can again paste the same code, but make this 4/5 of the way along that distance. The final scenario is when AL is less than or equal to 2100. As all the connectors will be unsuppressed in this scenario, there's no need to include a suppression list, but instead I'll just add a comment to say that all are unsuppressed. I'm going to copy and paste the code from the scenario above, and this time the region must be split into 6 areas to include 7 equally spaced connectors. So I'm just going to change the divided by 5 to divided by 6s. Now, if we continue watching the video below, so connector 3 will be, as usual, a sixth of the way across. Then connector 4 will be 2/6 of the way across. Then connector 5 will be 4/6 of the way across. And then connector 6 will be 5/6 of the way across. And then connector 7 will be the default central position. So I'm just going to adjust this code further. So for C5, I'm going to make it 4 times. And for connector 6, I'm going to make it 5 times. And then as C7 will be the default central location. It won't need a line of code, but I'll just put a little comment to say that C7 will be the default central position. So once we've saved our connector library, we can now put it into practice and see if our connector is working as it should. So I've got a simple frame opened up, and I'm just going to rotate it to the area of where I wish to add my connectors. And then in my connector library, you should now see your graphic series, which you should be able to drag and drop. Remember, you can press the tab key to change orientation. And then let go, and you can see there our new connectors have been inserted. Just going to edit the frame and just check our rules are working. So I'm going to change the depth of our frame to be 100, and hopefully now after a rebuild we should get 0 connectors like so. Going to change the depth to 300 millimeters, rebuild, and we should now get one central connector in the middle like so. Going to change the depth now to 600 mil, hit the rebuild, and we now get 2 connectors with a 32 mil offset from either side. Going to change the depth to 900 millimeters, and we now get 3 connectors with one in the middle. And finally, just going to change the depth to a larger value of say 2500, and we should see the full 7 connectors should be inserted, as you can see from the preview. So as we adjust the depth of our frame, the right amount of connectors will now be inserted based on our rules. In your feature tree at the bottom, you'll see this new connector feature, which you can right click and edit to adjust any further details if necessary. So that is the end of this video. Hope you guys enjoyed it. If you do have any further questions on creating connectors or on the general usability of SWOOD, then do not hesitate to give us a call on 01926 333 777 or drop us an email at support@solidsolutions.co.uk. Thank you for watching.